It turns out that once our engineers dug into it and they got a sense for how graph databases worked, they started to realize that when compared to our traditional use of relational databases, it was actually a lot easier to get insights from the graph by just traversing it for the answers that we needed, as opposed to super complicated joins in a relational database.
Welcome to another Hatchpad Insight. I'm Tim Winkler, the creator of Hatchpad, the community for startup technologists. If this is your first time here, don't forget to hit subscribe for updates on new insight interviews like this one. Today, we are chatting with Greg Mundy, the VP of Engineering at BrightHive, a public benefit startup headquartered in Chicago. Greg, thanks for hanging out with us at the Hatchpad.
Hey, great to be here, Tim. Thank you for having me.
Yeah, excellent. Why don't we just jump in here and start with a quick intro on your background leading up to your current role with BrightHive.
Sure. So I grew up in Jamaica, actually. I moved to the United States, specifically West Virginia, for college. After finishing a bachelor's and a master's degree in computer science at WVU, West Virginia University, I just decided that I really like the calm, laid back vibe that we have here in Morgantown. And so I just figured, hey, I want to make a life here. So I did. So at the start of my professional career, I was an assistant professor of computer science at a small university just an hour south of Morgantown, a little town called Philippi, Alderson Broaddus University. After a few years at Alderson Broaddus, I got into the thriving government contracting world that we have here in West Virginia. I worked for a company called Global Science and Technology, where we were doing some really interesting work on a number of NASA and NOAA contracts. Later on, within GST, I moved to their commercial weather group, which was a small but highly impactful group within the company. And we spent a lot of time building out new as well as maintaining existing meteorological systems that were used in meteorological and public safety offices across the world, particularly in the world of aviation meteorology. Through that, I actually had some really cool opportunities to travel all across the world. I've been to places like South Korea, El Salvador, the Cayman Islands, Belize, Mexico, to name a few. But as it turns out, a few years ago, my wife and I learned that we were going to be having twin daughters. And so I decided I really wanted a little bit of a change of pace, maybe not as much traveling. And I decided to join BrightHive because one, I knew a number of the folks at the company, including our current CEO, Matt Gee, met through some previous volunteer work that I had done with Matt and others in workforce development. And so the mission for BrightHive was just really exciting, and it was something I wanted to be a part of. And in addition to that, being 100% remote company, it was a really appealing thing to me as a new parent because I felt that, at that point in my career and my life, I really needed that sort of flexibility. So this is where I've been for the last 3 years, and it has been an amazingly fun ride.
That's a great journey. I'm curious, so as the VP of engineering, is there a CTO in place, or do you kind of stand in as a CTO within the organization?
No, there is a CTO. So our CTO and co-founder, Tom Plaguey, he's, like super knowledgeable about data and data science in general, data management. He's just an all-around awesome guy.
That's great. Why don't we learn a little bit more about BrightHive and what you all are doing as a startup?
Sure. So if I were to capture what BrightHive does in a summary, we're really mission-driven organization. Our goal is to help organizations discover the power of their combined data by providing them with a data collaboration platform where they can responsibly share their data with each other, resulting in increase in their value and their impact. And so we work in a space where oftentimes you find that data collaboration, data sharing is not something that a lot of organizations know how to do, or even know how to do very well if they do try. And so by providing the platform that enables the business, legal, and technical aspects to be in place for this data collaboration, it makes the process a lot easier and a lot more transparent to the customers. So that would be what I would consider to be our overarching objective as a company.
Excellent. Yeah, it leads us right into the topic that we're going to be talking through this afternoon. And obviously, dealing with data, there's all sorts of areas of data,
Mhm.
privacy, security, I'm sure is something that's pretty key as well. Um,
Absolutely.
but let's talk a little bit more about the databases that are storing this data. We want to talk through some of the comparisons between traditional relational databases and graph databases. And it seems at BrightHive, you all are using a combination of databases. So I'd love to hear what you all are doing with different databases to satisfy your mission.
One of the things that I've always been a huge advocate for is being able to use the right kind of tool for the right job. Taking that sort of approach in thinking, we use a lot of different database technologies at BrightHive. As an example, if we need to store large volumes of mostly unstructured data in a very cost effective way, then we tend to go for the NoSQL alternative. We actually make use of AWS for a lot of our infrastructure. And so we would use AWS DynamoDB for that sort of data storage. It's data that we know just by nature is unstructured, and it's really hard to put a schema on that sometimes. So by being able to make use of technologies like DynamoDB, we're able to store this data in a very efficient and cost effective way. There's not a lot of need to actually do analytics or sophisticated queries on the data. Sometimes it might just be data that's stored for a bulk pull that some end user would do. If we're doing anything related to data analytics, data warehousing, then we would most likely go for a database solution like Amazon Redshift. That's the purpose for Redshift, to be able to provide the data warehouse backend that we can use to do simple to moderately complex analytics. When we have highly structured relational data, we will go for PostgreSQL. More specifically, we make use of Amazon Aurora, which essentially emulates the behavior of a PostgreSQL database, but at a fraction of the cost. And so, sort of thinking through these things, we see that there's so many differences in the data that we work with, and being able to understand where that data lies and how that data is structured and the needs of the data for the end users is a really important decision making point for us. Graph databases now, they are really important to us, but in a little bit different way. We think of the graph database as really the enabling technology to unlock insights and provide visibility into the data by our end users. And so transparency is really a big thing for us. We want to be able to allow insights into the data, how the data is actually used, which is really critical for responsible data sharing. But by using a graph database, we're able to construct a knowledge graph that connects people within a collaboration to the organizations that they're affiliated with, as well as be able to link those organizations to the data that they contribute to the collaboration. And this can all be organized around very specific use cases that indicate, what the data shouldn't be used for. And so by providing that sort of visibility and transparency, it provides a little bit more sanity to the process of collaborating on your data, which is in and of itself a very tricky thing.
Very neat. What is the learning curve for your engineering team in terms of, getting a grasp on a graph database?
I'm glad you asked that question. So most of my development team, before we decided to go this route, they hadn't really worked with graph databases, but graphs were pretty intuitive to folks across the team, right? They're pretty simple structures. In computer science, we see it all the time. You have a graph that's made up of nodes and edges. In concept, it's not very complicated when you think about it. but to actually figure out how to apply this concept of nodes and edges to an actual production type issue, that becomes really interesting. So there's definitely quite a bit of a learning curve associated with graph databases, particularly if we've been in the realm of working with relational databases for a long time. So for us, it turns out that we use Neo4j as our graph database of choice. And Neo4j has this really interesting syntax. Of the many languages that it actually supports, there's one specifically called Cypher, and you can write your queries using this cipher notation, which is actually really cool because it's almost like ASCII art to query a database. And so it turns out that once our engineers dug into it and they got a sense for how graph databases worked, they started to realize that when compared to our traditional use of relational databases, it was actually a lot easier to get insights from the graph by just traversing it for the answers that we needed, as opposed to super complicated joins in a relational database. I'd even go as far as to say that some of our engineers really got hooked on the tech. And the question became, when should we not use a graph database? In my opinion, I know that graph databases, they're great, but they're not necessarily a silver bullet for any kind of data problem that we have. The one thing that we tend to ask ourselves when deciding on our graph database solution over something else is, what are the parameters of the data? If, for example, the data happens to be not very well structured, not doesn't have a lot of relationships, and that sort of connection between the different elements in the data isn't really important, then a graph database might not necessarily be the best fit for that. But overall, once we've gotten over that initial learning curve, there are still a few points that we had to learn, especially about managing a graph database in production. But once we got the hang of things, it really helped us to boost our ability to unlock these insights through our knowledge graph.
Decision was it to start working with these graph databases? Was that an early on decision in the product roadmap, or was that something that was later on in the product lifecycle?
I would say that a lot of it is really driven by our CEO's vision. When he was talking to customers, people were really craving this understanding of not only what data they had, but how they actually made use of that data. And so he had this early notion that, this knowledge graph would be a tremendously valuable thing to our product. And so when we realized, that we were at a point, especially as we were shifting from more of a services to a SaaS platform, we realized that we had a great opportunity to really bring a lot of his vision into the platform by enabling this graph database technology on the back end.